We're live. Hello, everyone listening to the recording. Welcome to the Computer Over Data Working Group. I think this is meeting number 16 for us. So we're chugging right along. And today we're fortunate to have Sami from Taubyte joining us to tell us about Taubyte, the community they're building, the platform they're building, how we can take advantage and start using Taubyte for some decentralized compute needs. Quick advertisement. We have COD Summit coming up May 9th through 10th in Boston, Massachusetts. So please, if you have not, go to codsummit.io, and I'll post the link here in the chat as well. We'd love to have you join, give a talk. If you've got something interesting to tell us about, sponsorships opportunities are still available. So if you're a builder in the space and you want folks to find out about your project, we'd love to have you on as a sponsor as well. So please join us for the event. It's going to be a good group of folks that are building in the community. With that, I will turn it over to Sami. Thank you for joining us, Sami, and I'll let you run with it when you're ready.
Yeah, sounds good. Thank you, Wes, for inviting me to this talk. Love the opportunity to share what we're building and what we've been building for some time now, which is basically decentralized cloud computing. So I'm the founder of Taubyte, and Taubyte is kind of like a cousin of Bacalhau to some extent. Like Bacalhau is more like a batch processing, decentralized computing, where at Taubyte we focus on serverless right now, so like real-time decentralized computing, more like cloud computing, because when you look at what made internet successful, it's actually cloud computing, right? So most of not most, but every application that everybody uses is almost powered by the cloud, right? Or cloud computing. That includes Web3 apps as well. The problem that is today is cloud computing implementations are centralized, right? So cloud computing itself is just a model. It doesn't have to be centralized. It can also be decentralized. And this is kind of like the path that we have taken. It was like, let's implement or re-implement cloud computing in a decentralized way. And this is important because cloud is an amazing tool, or cloud computing is an amazing tool to enable innovation. Like when you have a tool where you can run all-purpose computing in a decentralized way that enables a lot of things, that also reduces cost. So you can build faster, you can build truly decentralized applications and solutions, but you can also avoid relying on, let's say, expensive oracles, for example. So you can build your own oracles instead of having to rely on what's existing and kind of like have to bear all these fees, or relying on one featured protocols and stuff like that. So I'm going to share a deck here just to go over like how it works high level, and then I'll show you some things that I've built quickly for this goal. And then I'll show you go to present mode.
Can we just check that? If you can hear us okay?
Can hear you. Can you hear me?
Oh, a little bit. It's cutting in and out, but sometimes I'll just go on video mute, see if that helps.
Okay. Okay, I'll do this. Let's do this. And then try to my can you hear me? Okay. Can you see my screen?
It's coming across. It's starting to.
Okay.
Oh, here we go. Got it. Okay. Decentralized cloud computing. Looks good.
Okay, awesome. So I talked about some of the some of the slides I already talked about. So I'm just gonna move straight to what we've built and how what kind of layers we have and what kind of technologies we use. So if you can see the diagram here, and there, on the lower layer there, you can see that we're using things from IPFS, so LEAP, P2P, DAG, DHT, and stuff like that. So it's basically IPFS compatible. And then on top of that, we implemented cloud features as peer-to-peer protocols. So registry is a peer-to-peer protocol. CI/CD is implemented by 2 protocols, and so on. And then on top of that, we have the execution and orchestration layer, which has the Taubyte WebAssembly virtual machine, which is an all-purpose WebAssembly virtual machine that powers D functions, or decentralized serverless functions, and smart ops, or what I also call serverless ops, which are basically serverless functions that are executed before provisioning and can alter provisioning. So for example, you can say do not execute a specific function unless the node that's running the function has a GPU or is taking ETH. You can also alter it in different other ways, like leveraging 5G APIs, saying like, hey, do you have a specific slice, or provision the slice before provisioning the function or the storage or whatnot. Then on top of that, so it's a cloud native serverless interface that's Git operated. So you alter your project and the state of the network, push into Git, and you push your code to Git and your config, and then that's built and pushed into the network by the CI/CD protocol. And on top of that, we've built tools. So a web console that I'll show here shortly, Tau CLI, which is a command line. And then we have other tools that we've built too, like Dreamland, which is running like a little Taubyte cloud network locally in your laptop, so you can try things locally before pushing to a specific network. And then Taucorder, which is kind of like a tricorder, but for Taubyte, and you can explore the network, troubleshoot protocols, stuff like that. From a deployment perspective, so Taubyte itself is not like a service provider. We are building a software that organizations can deploy to create clouds. In our visions, we see millions of interoperable clouds that people can use. Some of them will be private clouds, and some of them will be public. The public ones, some of them will be, powered by tokens or crypto, and some of them will be regular fiat-based networks. But all these networks will be decentralized and permissionless. and like developers can leverage, multiple of these networks at the same time as well. From a deployment perspective, so we created like tools to deploy it easily. So deploying a network is or joining a network is a very simple YAML config. Then running a command line we call Sport Drive. If in the audience there are some trekkies, you recognize what that is. And you just do Sport Drive displace, you give it the name of the network, and you have a new network deployed in a few minutes. Or you can join a network with your nodes like that as well. So why did we start with serverless? So serverless is very powerful because we can treat it as just like content addressing. So it's like combined with content addressing. Now our serverless functions are location independent, and they're also immutable and can inherit all the nice features that a file on IPFS has, like immutability, verifiability, and so on, deduplication. And then we use WebAssembly because it's portable, it's interoperable, so you can use multiple languages. Like every module could be a different language, and they can talk with each other. Like for example, you can write a ZK proof with CIRCOM. The witness compiles to WebAssembly, and then your function could be Rust or Go, and they can communicate with that. Or we also did like a lit protocol integration. Their code is Rust, but you can call it from either Go or Rust. And then the cold start, which is a serverless term, like how long it takes for the function to be available, like provisioning the container or provisioning the WebAssembly runtime with the modules and everything. It's way shorter with WebAssembly, and with predictive provisioning can be kind of like virtually zero. And then there is possibilities to verify build and executions that we're working on and exploring as well. So this is like what function looks like. It's very simple code, and this is just a very simple function that takes an HTTP event and return pong. It like Go and Rust, and it goes well with the diagrams I'm gonna go through. So kind of like explain how a request on Taubyte works, and that way you have like an idea how it's different from a centralized system. So let's say we have a client, it's trying to get a specific endpoint, so example.com/ping. The way it works is the first request is a DNS request always, and the resolution happens through a protocol instead of a static DNS server or Cloudflare or whatever centralized DNS server is generally used. So that goes to a node running what we call the SEER protocol, which is connected to peer-to-peer network, knows what's going around, and it will grab the nodes that have capacity, their IP addresses, and return that to the client to be serviced. So the client establishes an HTTP connection. It says like, okay, give me /ping. The node that has been selected by the client will execute the serverless function and return pong, right? So just kind of like high level. In details, a little bit more things happen. So when the client sent that like HTTP request, the node might not know what example.com/ping is. So it's going to connect to nodes that run the Taubyte name system, and it's a registry protocol, and it will say like, what is this? Can you tell me what exactly is this? And TNS will return informations about what that is. In this case, it's a defunction, and it will return things like the ID of the defunction, parameters like how much memory, how long it will run, like the time to live. And one of the things that's in there too is the WASM module CID. And so the node will grab the CID from all their nodes if it doesn't have it, We use another protocol to do pinning, and we don't call it pinning, we call it actually hoarding. So nodes stash like CIDs to make sure they have a specific number of replicas. It's a better way, we think, to have a cloud native way to define replicas. So you can say, when you configure your network, I want 3 replicas, modules, and the net will do its best to keep a minimum of 3 replicas. If you say like, and then when you create a storage like resource, you can say like, hey, for my storage bucket or distributed storage bucket, you can say like, keep 5 replicas, and that can differ from one project to the other, and Hoarder will make sure that is the case in the network. And it's also decentralized, so there's no central entity that's doing like pinning or anything like that. So once the module is retrieved, dependency will be parsed and loaded. These dependency could be in the same project, CIDs as well, so other TNS requests will happen. It could be just other modules in IPFS, or they could be in HTTP. We have a plan to have like a kind of decentralized repos for modules. We don't have it yet, but for now, you can just grab modules from local repo, local project, or like an IPFS, IPFS CID, HTTP, and so on. So these will be loaded, the SDK will be loaded, and then the function will be executed, and that's what returns the Pong response. And just to resume, recap all of that, like DNS request, for example.com, Seer does that. It's dynamic. It looks what's going on the peer-to-peer network, returns that, and then the second request is this next request is HTTP to one of the nodes. The node grabs the function, executes it, and returns the response. And you might think this is all slow, but it's actually very fast. There is caching obviously happening as well. So we did some benchmarking compared to AWS Lambda. It's 8 to 10 times faster. So basically, Web3 faster than Web2, just like, or what it should be. We built tools, so the tools I was talking about, I'm gonna walk you through some screenshots, and then I'll walk you through the real thing, like a little demo here. So Web Console, it's a very easy tool to use to build your project. So it's just console.taubyte.com. CLI, it's a command line that's very easy to use. We made it so it kind of like reads like English, like tau new function creates a function, or tau new project creates a project. And then Dreamland is running, Taubyte network locally. It goes with Audible, which is like the graphical interface. You can see your nodes, you can add nodes, kill nodes, run fixtures, and stuff like that. And then we have more tools that I talked about, so Sport Drive, Tau Hoarder, and Queue. And then this is something I wanted to show. Actually, so this is a IPFS gateway, or a serverless IPFS gateway that I've built during IPFS thing. It's roughly like 40 lines of code. So you can see there that it's getting like an HTTP event, grabbing the CID from the query, and then parsing the CID, creating an IPFS kind of like a shadow node, because like it's just kind of like making an interface to WebAssembly. There is only one IPFS node in the node, which is the node itself. And then it's going to open the file, give us a reader, and we're just gonna like take that reader and send that over to HTTP, and the client will get it. And I did this pretty quickly, roughly like 15 minutes. And for today's presentation, I even added some image processing. So let me stop sharing this screen, and then I'm gonna share another screen with the code here. Give me a second. Okay. Okay. All right. So this is like the same endpoint, and this is like the same endpoint processing the CID. So basically, grabbing the CID. Sorry, that's gods of demos not being happy at me. Okay, so grabbing the CID from IPFS, doing some processing, and then sending that to the client. So let me show you what it looks like. So going to log out here just to show you like what the web console looks like. All right, so web console is just a web interface that is actually going to clone your repos instead of anything else. So there are a couple networks here. So there is the old sandbox that's deprecated. There is the new sandbox. You can, if you have Dreamland running, it will show Dreamland here, or you can connect it to your own custom network as well. So I'm gonna log in here with my GitHub. Gonna go fast because I already have that going, and then I'm gonna open this project. If you have a project elsewhere, you can just import it, just registering the repos in that specific network. The network's not really like there is no login or whatnot really in the network. Your source of truth is really your repos. So this is the project that I have right now. That's the IPFS project. So you can see here, these are the locations of the nodes in this network. And then I'm going to go to functions, and I basically have two functions. The simple one that you've seen before is this one. So it's just get the CID, and then returns. Let me make it slightly bigger. And then basically forwards, the content to the client. The one that's doing processing, let's look at this one. It's exactly the same function. So it's HTTP. It takes 10 seconds to run TTL. What it will be kind of stopped if it takes more than 10 seconds. 10 megs of RAM. It's a GET request. It is connected to a generated domain, and then it's on /build. This is the YAML config that's also on the repo, and then the code is right here. So I'll show you what's different. So get is basically the other get. So it goes to IPFS, grabs the file, returns the read closer. And then build, because I'm using the build library, just called it build. So it's going to get the reader using get, and then process it or make an image. So image.decode. Note that I also imported JPEG here. Otherwise, you won't decode JPEG. And then it's gonna invert, resize, and rotate, and then convert it to a PNG and send it over to the client with the right here. Right, so super simple. I made this in a few minutes. You can also, and then once you made modifications, you just hit like push here, and this will kind of like walk you through like what was modified, and like did you modify code or config or whatnot. So I'm gonna do actually something here. I'm gonna create or host like a website here quickly, just to kind of showcase how easy is that. So I'm gonna call it COD Cloud Simple. So I'm gonna leave it to generate here. So the the interface here will generate like a repo for me. For domain, I'm gonna use the generated domain here, and we're gonna host it on slash, which is where most websites go. And I'm gonna hit OK here, and it's gonna ask me to select a template. I mean, you can do whatever you want. I'm going to go with view here and hit generate. So this will generate a website. It's a separate repo that's being added to the project here. So now in my project, I have a repo or a website. I need to push that config first to tell the network that now I have like a website, and I'm gonna push that. So this is just config, and say like added website, and hit finish. So this is going to push to GitHub. Like there is nothing like really special here happening. If I go to config repo, you can see my commit here, added website, and this is the YAML file I added. If I go back to this interface and go to builds, you will see the build here that should show up here. Okay, so it's a config build. It was successful. So nothing happened yet because the website still needs to be built. So I'm gonna go to my website, open the repo of my website, and modify something here just so I trigger a build. Let me modify actually the let me modify the source here. So welcome to, I'm gonna commit. So this is going to trigger a build. So if I go back here, go to builds, you can see here that it's triggered the build of the website. It's not a magic build, obviously. If you go back here or to any of your functions, you can see like there is a Taubyte folder that has like a config YAML that describes how it should be built. So this build we're using like a Node.js container, and it's running the build script here, which is just doing like yarn install, audit fix, and then yarn build, and then move in whatever was built to /out. Let's see if the build is done. It's successful. You can download your website here. You can see the logs of the build as well right here, and the logs are also a CID in the network, obviously. And then let's go to the website here and click on this little like thunder icon, which will open the website. Oh, good. Demos. Okay, so this is our new website. So welcome to Code Cloud, and this is hosted on a generated domain here. The network will also get like a certificate from Let's Encrypt Dynamically and reply with this. That's super easy. Same thing with functions. I can create a function here, very easy. If I go to create a function, you can just do select template, and let's do Rust for a change. We're gonna do a ping pong with Rust. YAML describes the function, cloud native, like I said, and then the code here is our code. We're gonna do code.cloud loves Rust. And then hit enter. Same thing, by the way. So you can see this is like the build script to build this module. And then we're gonna attach it to our generated domain and give it a little path here. So we're gonna call it Rust. And hit enter. And push everything so it compiles. So we have like config, which is basically like defining the function itself. We have the code that's right here. And obviously you can also create separate repos for code. That's what's called libraries here in the interface. on the Rust code, finish. So this is going to push to GitHub. So if I go to project detail and go to my code repo, you can see here added Rust code, and that's my diff here. Moving back to build, you'll see that there is a build happening. There is a build happening right here. Let me see. This one. So there is a build happening. It should be done in a few seconds here. And then we can execute our function. Obviously, it's Rust, so it takes longer to build than Go. Like you'll know that Rust is not like, or Go actually was designed to build fast. It's gonna take some time here before it builds. All right, boom, so successful. You can see here like all our functions. You can download the WASM file of any of them. And then if I go back to my function, and this is my ping pong in Rust, and just go there. Okay, let me refresh this. Okay, so cloud.cloud loves Rust. So that was executed by a node in the network, and your function is live just like that. Very easy, very quick. You can explore your config. If you go to config production, you can see what TNS is seeing for a specific project. And then everything I did here can be done in command line as well. So if I have like a little bit of time here, I don't know if I do, I could show you how all of that can be done in Tau. Do I have time, Wes? Or should we reserve that for questions?
We do have time.
Yes. We've got at least another 15 minutes.
Okay, should we do questions or?
Yeah, let's do questions as well. And actually, just to kick it off, one question for you. It's always interesting to see folks in the community which types of technologies they prefer to start with. Some people will start with batch technologies. Some people are more Kubernetes centric, or they want to implement something like EC2 and obviously serverless functions, which the direction you've taken with Taubyte is probably the most popular. But could you just share more about when you were getting started and you were looking at different architectures, how you got into the thinking of settling on this architecture? What was the driver for you? Were there any trade-offs you were thinking about?
Yeah. So the reason we went for the decentralized architecture first was because we wanted mainly to enable cloud computing for Web3, but we also wanted to kind of like doing that enable horizontal scaling, which is very important for edge computing. Like how do you scale horizontally through different through like a large number of servers that are or devices that are in different locations, and also most of the time owned by different peoples and organizations. And this is why we can excel on this architecture. And Leap P2P and IPFS was like a technology that made sense to leverage to build on top. And then Leap P2P also offered a lot of nice primitives like streams, so we could build peer-to-peer communications. And then WebAssembly, like from the kind of like execution side of it, WebAssembly made sense because it was something that's very interoperable. You compile once and then you can execute it on different architectures, especially when you're scaling horizontally. You don't know if the node is going to be an Intel an ARM or something else. So you want that code to run all over the place. We wanted to enable interoperability between languages, but also WebAssembly is easy to verify. So it's easy to verify the code that made it like immutable. And like FVM smart contracts are WebAssembly, right? So and like you cannot modify the code without modifying, in our case, the CID, and we can verify that, like nodes can verify before execution. And then there are a lot of things happening in WebAssembly, so it's easier to secure the context. It's easy to create like plugins and make development easy for developers, like provide powerful tools and SDKs. And then there are things happening like verified builds and verified executions that we are looking into also integrating with Taubyte. So with, of course, there is also a trade-in, like if you want to like trade in speed for verified execution, and you could like compile your WASM code to generate a ZK proof, and it's gonna be like a modified WASM file that at the end will generate a ZK proof, and that ZK proof can be used to prove that the execution was correct, right? But obviously that's gonna be slow. But there is also always a trade-off there. But WebAssembly definitely a powerful tool. And I mean, we believe that most software is moving toward being serverless. So that's why we went the serverless route.
Fantastic. I love it.
Gmo, I'll give you some space if you have any questions as well. No, I got one more for Sami.
So, Sami, one
Last question for you. In terms of use cases that would take advantage of Taubyte, would you like to see folks building websites on Taubyte? Would you like to see them doing decentralized finance things? Or what sort of scope of use cases would you like to see over the next few months?
Yeah. They're like from a developer perspective, like would love to see like people hosting like front ends and building or kind of like moving that backend logic that's in general in AWS Lambda and other places to be decentralized. Also building like instead of relying on rigid and expensive oracles, maybe building their own oracles, and basically accelerating development in general. From a deployment perspective, like we have tools to easily deploy networks, and we would love to see networks being deployed and created. Whether it's a network that's publicly available so people can use it, and if you want to like monetize your infrastructure, or you can also use Taubyte to create a protocol. Let's say you're creating an AI protocol, or creating like a gaming protocol, and want developers to have more powerful tools, not just API calls. So they have like D functions and storage and key value stores and direct access to your primitives through WebAssembly, which makes it way more powerful and way more versatile to build interesting things.
Fantastic.
Yeah, and then just kind of like, if you don't mind answering like a question here. So we have a website for documentation. It's tau.how, TAU.HOW. And then we have a Discord server, discord.gg/Taubyte, if you need any help with anything.
Very good. All right. Well, Sami, do you want to?
Spend any more time
Cool.
showing any other things to wrap up, or do you want to go ahead and call it a wrap for today?
Yeah. I need to go downtown Austin to join the Econ Day downtown. So yeah, I mean, thank you for the opportunity. There are some videos on Taubyte how, and then we're happy to help and answer questions on Discord at any time. So yeah, please try it. Give us feedback. Break it if you can break it too. That'll be awesome. So we can fix it. But yeah, thanks for the opportunity.
Yeah, thank you so much
For presenting today, Sami. Looking forward to seeing you at the COD Summit, and good luck at the conference this week.
Yeah, thank you. Bye.
Take care. Bye-bye.